Hello everyone, welcome to my channel. So in this video, I want to talk about the intervals, and this is also important materials for our topics in statistics. So in last videos, I've already introduced how to use the point estimator to get the information of our population. So here I want to give a quick summary about this one. So here, for what we do here is, in general, the probability is more focused on the left-hand side of this picture. So it means it's more focused on the materials about our population. However, then when we go to the statistic, then what this is means we generally have more information about the sample. So for the sample, this in general is a subset of the information we have in the population. For example, this is a sample can be a result from a survey, or use this survey we can get some data, right? And then we want to use this data to guess what is the general conclusions about the whole populations of the pools. So for this one, actually, this process is what we call the statistical inference. So that means we use the statistics, which is some functions of our results in the sample site, to guess the results or the conclusions of our population parameters. So for this statistical inference, in general, there are two main branches of this process. So the one is about the parameter estimations, and the other is a hypothesis testing. So of course, in these channels, I will introduce all of these materials. So for last videos, we already talked about one important part for our parameter estimations. So this is what we talk about, the point estimation. So for this point estimation, actually we use how about like 3 or 4 videos to talk about this. So if you didn't look at them, please look at my previous videos. So we talk about how to do a point estimation and how to compare different point estimations with each other. And then the other important part of our parameter estimation is what we want to talk about in this video. So the name of this is statistical intervals, and also we call this like confidence intervals. So for this confidence intervals, this is also a part of our point estimations. Right, so that means this is also related to the estimator. So what is a confidence interval? In fact, we use this one to answer a question. So for the point estimation, this is answer a question is what is the value of our population parameters. We use one statistic values to say this is our value or our estimations of the population parameters. And then for this confidence interval, so this is answer a question is if we already have one estimator of our population parameter theta, then we want to know how close of these estimators to our true values, or say how close the true value theta is to our of our estimator theta hat. So to do this, what we will do is to measure this, we will use a value of our theta hat, the estimator, to build out an interval of the true value for the likely values for our theta. So let me write down of these statements. So here, this means actually here we want to have an interval. So this interval, what there have some special of this. So in general, this interval is have our true value. For example, the theta is in the middle. And then this will have left in the point and right in the point of this interval. So in general, to make this is easier, actually we have this as a symmetric interval with respect to our true value theta. And then also this is, for this range is a range of plausible value, for example, like the likelihood. So that means here what we want this is in probability with a specific value. We want this interval have this requirement. So that's why here the confidence interval, the definition is looks like. So this is what's this definition. So here the confidence interval, we also denote this by C dot I dot, or in some textbook they generally denote this by CI. So this actually is a true interval. This is have a left in point and right in the point. And then what like how we find this one. So the idea is we want to find L and R as these two endpoints to make our probability of the true value is fill inside this interval with the probability is equal 1 minus alpha. So here this means if we change the value of our alpha, then the probability will change. And then in other words, the value of our L and R, these two endpoints will change. So here R is a very important parameters in our terminologies in this statistic intervals, or say this confidence intervals. So here generally we call this R is the confidence level of this confidence interval. So of course this is how to write this in the mathematics, use the probability. And then we can also explain this in some like language, general language. We can also rewrite this as this equation. So here, there of course the value of our R can be any value just between 0 and 1, because we know the probability is always between 0 and 1. So 1 minus R should also be between 0 and 1. So that will give us the value of our alpha is between 0 and 1. However, in general, for this probability, we just want our L and R, these two endpoint is very good. So that means this is good enough to make most case our true value theta is between this interval or inside this interval. So generally R is a number very close to 0 to make the 1 minus R is very close to 1. So here there is some very common value of our R. So in general, we can choose R is equal to value 0.1 if we don't need the probability really large. So here that means this will give us probability is about like 0.9. And also alpha can equal 0.05 or 0.01. So this will give us our p-value is close to 0.95 and 0.99. So here this means when we have this alpha is much smaller or decreasing, this will have higher chance for our true value of parameter, the population parameter is filled in our confidence interval. Okay, so this is some terminology of the statistic intervals, or we can call this confidence intervals. So to compute this, or say to find our left endpoint L and right endpoint R, what we need to do, this is we need to try to, based on the population we have, or based on this CDF or the information we know about this probability, to try to find this symmetric intervals. So actually in the previous videos, when I in the channel or in the playlist of this probability for normal distribution, I already give one example of how to use the table of our standard normal distribution to find the value of this L and R to make the probability of one one random variable is between this one to get a specific probability. So I strongly recommend you to look at that videos, and I will also put the link of this one as a chart here. So then in next video I will start to talk about if we know a specific assumptions of this population distribution or sample distribution, then how we can use the tables to help us find this left and right endpoint L and R for this confidence interval. So please subscribe this channel, and I will see you in next video.